Hello. Well, a few weeks ago you'll have seen me working on a Tascam DA-45HR, this beautiful DAT machine. And I've got it fully working, and that's a wonderful thing. So why am I talking about it now? Look what I've just bought! I've just bought another one. How silly is that? Now, this one apparently is dead, and the seller said, might be a fuse. Well, you know, we know better than that. It's not going to be a fuse, is it? And if it is, there's a reason. So let's have a look at this one. Now, my last one had a bit of a dent in the corner here, and looking at this one, it's got a dent in another corner. And a bit of a grubby mark there, but otherwise looks cosmetically okay. But it is apparently dead, so we'll adjust things here. We'll put that there, get all this bubble wrap off, plug it in and see what it does. And I'll get the tape out of that one ready, just in case we're lucky enough to actually fix it. Okay, looking at this one, it's got a lot more scratches in the top, and a nasty dent there, but it does have all the cabinet screws, so that's a good thing. Lots of scratches in the top here as well. So, it's not exactly been looked after. Now, it's apparently dead, and that makes me just a little bit nervous, so I'm not actually going to plug it in initially. I think we're going to have a quick look inside first. The power supply, I think on these, is a straightforward linear supply, not a chopper supply, which should make debugging that a little bit easier, but of course there's every possibility it's not a power supply problem. There may be something else wrong. Let's have a look inside first. That screw didn't feel especially tight. Wouldn't it be lovely to get hold of equipment that's broken down and that people haven't been poking about inside of already? Right, there's the power supply there. I will meter the fuses, but you know, it's not going to be a blown fuse. Not a blown fuse. Not one of those anyway. Just going to take a quick look, make sure that nothing looks fiddled with. Do you know, our other DA-45 machine has an extra sort of bodge board up here. Let me just remind you, in case you didn't know, this is not any old DAT machine. It's 24-bit high resolution, so though it can record and play standard DATs, it can also record at double speed 24-bit resolution recordings, which is almost unique. It's a special DAT format, and I think this is possibly the only machine that supports it. So it's a rare thing, and of course the problem being that if people have got tapes recorded in this format, they can get a bit stuck if they don't have another machine to play it on. There are actually two more fuses there. I'll just check those. I'm going to provide a little bit of information down below on some software. Well, there's a YouTube video of somebody who uses a DAT drive for computer to recover digital audio tapes, extracting the data digitally. If anybody's played with that, do let me know if you think it's a good thing, if it's better or worse than using a proper DAT machine. Just try and get in there to these other two fuses. That one's intact. That one's intact as well. Alright, I'll plug it into the isolated power supply and we'll see what, if anything, happens. There is a door now. That's interesting, isn't it? I don't have the service manual for the 45, but I do have some information on the 40, which is very similar. Though the 40 and 45 are similar, they're clearly not that similar, because looking at the shape of the PCB, it's subtly different. One thing about this, though, is that it has a fan, and as far as I'm aware, the fan is always on. When the machine is on, the fan is on. I don't believe it's powered by any complicated electronics. So I'm just following the fan wires, here we go, back over to the power supply. So if the fan doesn't run, that does imply that it is a power supply problem. I think I've seen something. I'm going to get you on a different support, and I think you'll agree with me. We've worked out what the problem is. I was just looking at the fuses, and I noticed a bit of a mark. Let me zoom you in. Can you see something? Look at this fuse. What's this next to it? That feels like a crack in the PCB. Now, I think the transformer mounts on the PCB, so I suspect the unit's been dropped and the weight of the transformer has damaged the PCB. That's my understanding at the moment. So next I need to work out how to get the PCB out, the power supply PCB. Looks like I could take the deck out. I don't really want to do that. I think I may have to, though. Is there any other way to access that power supply? Well, oops. The bottom doesn't come off. This whole piece here is one. So it does look like you have to take the deck out to get the power supply out. Oh, that's a nuisance. Let's see if I remove this bracket here, how far I can get. Okay, so the deck's still in, but I've removed the bracket across the back of the deck. Maybe I'll have enough room to get the power supply out. Let's undo the screws for the power supply. This power supply is actually snapped clean in half. Oh my goodness. That's going to take some repair. Actually in two halves, look at that. Oh wow. How has it gotten to that state? Look at that. Oh dear, oh dear. Right. So what do you reckon? Do you think that that's been caused by being dropped? Or has it been caused by there being a fault with the power supply and somebody trying to take it out, getting into a kerfuffle and snapping it? Oh, look at the damage. So it's not just all the tracks that have been lost connecting these two halves together, but there are further cracks elsewhere. So there's I think a crack there and there. So we need to make sure we cover them all. But I think my biggest problem is going to be, how do I mechanically put the board back together so that it's strong? Need to be very wary of this here. There's a diode there, which I think is supposed to connect to one of the fuse holders there. So I need to be particularly careful where there's some components soldered here that they all finish up soldered to the right places. So what would you do? How would you give that the mechanical strength it needs? There's a section here with nothing on it, so maybe I can add a bit of strengthening there. There's nothing on the top side on either of these sides where the crack is, so I could probably glue something, glue a piece of board across both of them. And glue on the PCB itself, but what kind of glue would be appropriate? I suppose epoxy resin. Yeah, I think I'll epoxy right across the crack initially. And then we'll look at strengthening it. I think I'm just going to use the epoxy as the strengthener. Okay, I reckon that's pretty good. That's fairly well lined up. We've got plenty of glue on it. So let that set, and we'll see where we are after a good number of hours when that's strong. Well, the PCB is glued. I'm a little disappointed insofar as there's a small misalignment. I think you can see there that the board is slightly higher on this side than that side, only by a fraction of a millimetre, but it'd be nicer if it hadn't come out that way, but there we go. Now, one way of repairing PCBs, if it's a small crack, can be to take the lacquer off the top and bridge the tracks. But I'm not prepared to do that in this case for several reasons. One is that, of course, we've got the misalignment anyway, albeit not as big as a track. But anyway, these are going to be potentially some of these fairly high voltage and high current, being a power supply. So and the other concern is if you do bridges across like that, and then the board does flex again in the future, they could fail. So I'm going to use some pretty thick wire I have here. And although it won't be that elegant, solder wires from each start and end point. Now, of course, there's more chance of making a mistake this way than if you just put them across the tracks. but I just don't feel comfortable with patching out these tracks. So I'm just going to have to put wires in across the positions, say from this component through to this component, and make sure I don't make any mistakes and do it as neatly as possible. I think this wire is going to be too thick. I'm going to have to use something thinner. Right, there's the power supply now after fitting patch wires over all the broken tracks caused by the board having been snapped. And I've been right through and done a double check, because of course any mistakes here could be quite catastrophic. So I'm reasonably happy that that's okay to go back in the machine. But what I think I'll do in the first instance is just connect the fan, which was, I don't know which connector it was, but it'll be obvious. Fit only the fan initially and confirm that that runs up. If that's okay, then I'll connect the rest of the machine. So if it does go bang and horribly wrong, at least it'll only do so with the fan connected and not with all the electronics. I'm fairly proud of that. I'm quite happy with that's come out. The one thing I don't like, however, this capacitor is a very, very slight bulge. I don't know if you can see it. Just a hint of a bulge on the top of that capacitor. 3300 microfarads, 25 volt. I don't have one to hand at the moment. I've measured it on my ESR meter and it meters out absolutely fine. But it's looking at me with a bad attitude, so I'm going to change that. I'll have to order one in. Right, let's fit this into the chassis. Okay, we have the power supply refitted. The only cable plugged in is to the fan, and the power switch and the input power. Amazingly, the design is such that you could get these in the wrong way round. I hate to think what that would do, but they are correct. So I'm hoping that it won't blow up or blow any fuses, and that it will run the fan when I switch the front power switch on. And then if that's all okay, then we'll reconnect the rest of these wires and do some more testing. So start with power up. Nothing blew up. Switch on. Fan is running. That was a fairly good start. Breathe a little sigh of relief that we got that far. Let's reconnect the feeds to the deck itself then. Right, let's switch it on. Display is lit up. That's good. I'll swing you round to see the machine from the front now. Okay, so we'll power it up and let's see what happens. I'd be surprised if it works, but we'll give it a whirl. Tascam 45, that's all okay. Flashing word, I don't know why. Maybe it's that switch there. That's done that. Okay. Let's see if we can eject and close. That seems okay. I'd be surprised if it fully works though, because there is a drive belt which is known for failing on these. So we're likely to have more problems yet, but let's see what happens. This is a standard 16-bit recording. That's the drive belt, I think. The usual fault. Loading error. Yeah, that's the loading belt. Slipping as they always do. Let's see if we can eject the tape from that point. Mechacom error. Moving error. Come on, give me the tape back. So it's actually very similar to the some of the problems I was getting on my other deck when I first got it. Let's try to eject the tape. Don't know which way to turn the motor at the moment. Maybe I can't eject the tape just yet. Okay, I'm going to have to take the deck out and get to that pesky drive belt. Having to remember, I have to take it all apart, because it was some weeks ago, if you remember, that I worked on the other one. These screws are nice and tight, they've not been tampered with. Now what I remember is there's a tiny drive belt just in there, which always fails. But just also check to see if these belts are slipping. Let's take this bottom PCB off. And there is a ridiculously small belt which always slips. Let's take it off with a pair of tweezers. This belt, tiny belt, always just turns to goo. So I can't do any more until I have one of those. Okay, here we are a few days later, and we have from Germany our drive belts. They are quite expensive. They cost me, how much was it? Well, €15.80 it was for a couple of drive belts. But you can see, you know, they really are absolutely tiny. So it's not like you can work around it. You need these specific drive belts. Now this is just for the loading belt. There are actually 3 belts in the deck. But we're replacing the one we need to do right now. There's all the screws and the old belt. I think I got myself into a bit of a pickle. I got myself into the situation that the cassette stuck in there, but I'll work around that. Right, the fending belt is in here. Right, made sure any twists are worked out. Let's refit this PCB. Well, I'm wary of this belt here. Maybe just as well to change that, but I can do that even when this board is refitted. So if I have a suitable belt, I'll change that one. So to change it, I'm taking the gear off that's above that one. Right, I've changed those belts. There is one more belt, which is this one that does the carriage in and out, but I can worry about that one later because it's very easy to get to. Let's reassemble it and see if it works. Okay, hopefully that's good enough for now. Let's see if the deck runs. I've got loads more screws and stuff to fit, but I'll worry about that later once we've found out if it runs at all. Power it up. Let's try to eject the tape once it's booted. Oh, Mechacom error. Oh, that's not good, is it? Could that be a problem with the in and out position switches that we had on the other one? I don't think it is actually. Okay. See what it does if I just power it up now. Tray open. That's correct. Close. No. Not going to close. Tray close. Well, it's not closing. What's going on? It's odd because this worked earlier, a few days ago. Head drum's free to spin. This is free to go in and out. I'm not seeing any activity on this loading motor, which is the one that does the... This of course there's more than one loading motor in this thing. The one that does the carriage up and down. So there's one motor for carriage in and out, one motor for carriage up and down, and another motor does the lacing and I think the other deck functions. And this one here that is the one I've just changed the belt on, one of the ones I've just changed the belt on, isn't attempting to drive at all. It's free to spin, but it doesn't seem to be trying, so... Oh dear. Let's see what that motor's plugged into. Aha. I have a cable off. It's this one, isn't it? I took that off earlier when I was working on it. And like a fool, forgot to put it back. Have we learned something about being careful with cables? Okay. Try again. Ah, much happier. No tape. Try open. Read the time. Press play. Yes. Try a pair of headphones. So intermittent sound with lots of errors. You may just need a head clean. Right, very large error counts. That should be under, I think, 90 and it's reading thousands. B head, thousands. So, okay, we may need to set up the RF waveform, or it may just need to clean the heads. We'll have a look. Now, when I did this some weeks ago, I found the points on that board where I could pick up the RF output from the head and the switching signal. So I'll need to do that again with my oscilloscope. Although the error numbers are falling, let's just give it a moment to see the heads clean up. Well, one obvious thing to do is try a head cleaner tape. So I'll give that a whirl. Okay, head cleaner tape. Run that for about 10 seconds. And try again. Zero errors. I'm sure I expected that. Okay, have some testing to do and some reassembly. Okay, that's working. I will try the high resolution recording function later. We did that on the other machine, if you remember. Now, here's a question for you. These machines are 24-bit. There is another high-resolution DAT format, I forget the manufacturer, but I'll put it on the screen, who made a 16-bit but 96 kilohertz sample rate, whereas this is 44 and 48 kilohertz sample rate. So, which was the most important, to have a higher sample rate or a higher bit depth? Of course, today with modern audio recording, you can have both. I've got Tascam recorders that can do 96 kilohertz sample rate and 24-bit depth, but in these days, going beyond 48 kilohertz and 16-bit meant bending the DAT format, and two manufacturers did that. but which was the most important modification? More bit depth or more sample rate? So it might depend on the recording you're making. Right, I'm going to test this some more. I'm very happy with that so far. Looking good, isn't it? When I was going through the display just now, did you spot something? PowerPoint. Let's find it again. Drum hours. 1 hour. Is that for real? Or has it had a capacitor failure and forgotten its head hours? What do you think? Could it really have 1 head hour? Well, I've not run it for 1 hour, so it must have stored it somehow. That's a very interesting number, isn't it? Okay, it's now playing beautifully. That's the machine we've just worked on, and here is the one I did a few weeks ago. And a small difference you can see, I think, is that the brightness of the display on this one I did some weeks ago is not as crisp as the one I've just worked on. So maybe that 1 head hour reading is genuine. It really might be effectively a new machine. I've got these two hooked up at the moment digitally, so the digital output of this one is playing into the input of this one. And that is quite a sight when you consider how rare these machines are. To see two in one place, both in full working order, that's really quite exceptional. I'm very pleased with that. Well, I hope you've enjoyed this and learned something more about these wonderful Tascam high-resolution DAT recorders. Now, just before I go, there is one thing I wanted to mention, as of course we're all living through very difficult times at the moment. But it's particularly difficult for those of us like myself who are self-employed. There's effectively no help whatsoever from our government. Nothing for the self-employed, apart from, oh, you can collect dole if you want. It's not going to help, is it? You know, if you've seen my channel, you already know, I've got 3 kids, got a business to run, and our income has gone from what was already falling. It had already fallen somewhat due to the financial concerns, shall we say, possibly of Brexit or otherwise. And then so there's a loss of confidence in business, and I've seen business suffer somewhat over the last couple of years for that. And now it's fallen to as good as zero. And got nothing. We just have nothing to fall onto. You know, it's a very scary time for those of us who are self-employed. No help at all from the government. We're just cast aside. So there's no answer to that, is there? We're in a pickle. Well, let's hope things improve. Do remember to look after yourselves and take this seriously. You know, it's just bad news at the moment. I'll carry on doing videos about audio and video technology as long as I can. Obviously, I can't spend a lot of money on equipment or spares, and there's going to come a point when I can't order parts either. But right now, I do have a good old backlog of equipment out in the storeroom and elsewhere that I can work my way through, and some things I want to show you as well. So I'll certainly carry on for a good few months yet, and hopefully we'll all pull through the other side. So please do remember to like, share, and especially subscribe, and I'll do a lot more content on audio and video technology in the near future. Bye for now.